We excel in the production of carbon composites here at Rocket Lab. We've done a lot of R&D throughout Electron and Space Systems and now Neutron, so we know what we're dealing with and we can produce a really high performance light launch vehicle using it. This AFP machine is the biggest of its kind in the world. It's standing over 12 metres tall and can travel 30 metres back and forward along the work cell. We'll be tasked with building the biggest structures of the Neutron vehicle. This includes the 7-metre domes and barrels that make up the Stage 1 tank and some of the 12-metre long interstage panels that enclose the Stage 2. AFP stands for Automated Fibre Placement. It's essentially an industrial process that massively accelerates the laying down of carbon fibre onto a mould to build large carbon structures. This is a process that's traditionally done by hand. So the key performance metric of a machine like this is essentially how fast it can lay out carbon fibre. This is really important because our large parts are made up of hundreds of layers of carbon fibre and thousands of square metres. So the faster we can do this, the better. We can pay out over 100 metres per minute of carbon fibre. Currently it takes a large team several weeks to build a Stage 2 dome, whereas this machine will be able to punch it out in 24 hours. The machine's been designed to accelerate in any direction at 0.2 G. It's able to stop on a dime, turn its head around in a fraction of a second and start laying down carbon in the opposite direction. And it's little things like that that make this machine much better than the rest. This machine will be installed in our new facility in Middle River, Maryland. This is our space structures complex, which will be quite heavily focused on producing the large composite structures required for Neutron, but will also act as a centre of excellence for composites for the whole company. So that's including space system structures and Electron composites and all sorts. So this machine also includes a fully automated real-time inspection system. This is really important for composite parts because they're made up of so many layers. So it'll search for minuscule defects as it goes along and will notify the operators of any issues before it starts on the next layer. It means that we can sort of maintain our really high quality standards for spaceflight structures. Me personally as an engineer, I love machines, I love automation, and this is state-of-the-art automation. For the size of the machine, it's the highest performance thing out there, much faster at moving around than a traditional CNC machine, and there's some really clever smarts going on in that process to make sure that we lay down fast and accurate components.